All right, so if you would like to know how to do this activity, feel free to keep watching. Also, feel free if there's parts that you already understand and you don't really care about, fast forward through it to get to the parts that you actually do care about. All right, but first things first. So each letter in college stats class is written on a card and placed in a hat. Repeated letters are entered multiple times, so you have a C on a piece of paper, an O, an L, an L, so on and so forth, right? Consider the probabilities of drawing a card that fits the following events. So let's just talk about the event of drawing a vowel. So remember, events need to have, this is talking about their space, right? So they need to have those brackets. So what are all the vowels in college stats class? Well, we see there's an O, there's an E, there's another E, there's an A, and an A. So those are all the vowels. Now let's look at the consonants. All right, so again, you make sure to have your brace. So we got a C, we got two L's, we got a G, we got an S and a T, we got a T and an S, we have a C, we have an L, and then two S's. All right. And then lastly, F. F is a letter in the first half of the alphabet. So the first half of the alphabet goes from A to M. So what are all the letters that are A to M? So we can see there's a C, two L's, E, G, and E. We have an A, C and an L, and then an A. All right. So any other letter is outside. It's N to Z. We're not going to talk about those for that section. All right. So, what is the probability of getting a vowel? So let's write it out in fraction and decimal form. Well, how many vowels are there? There's 1, 2, 3, 4, 5. So that's going to be 5 over the total. How many total letters are there? We see it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 5 out of 17. When you put that into a calculator, you end up, if we round to 3 decimals, it's going to be about 0.294. All right. What's the probability of getting a C, a consonant? So again, we count how many are in the actual event. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And it's over the total, which we already said was 17. So that's our fraction. When we actually divide it out, we get 0.705. Well, I guess 706, because they should round up. All right. And then we have in F. What's the probability of it being in F? So counting it up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 letters in F over a total of 17, which we've already talked about. When you divide that out, you get 0.588. All right. So now we got the probability of the complement of F, right? So remember F with the C on the top, the C means complement, so this is the opposite. So we can actually write out what F of C is. So maybe we want to do it up here, right? So F of C, so these are all the letters that are not in F. So what are all the letters that aren't in F? So this would be the last half, right? The second half of the alphabet. So the ones that go from N to Z, specifically the ones that are not in F. And we see that that's just going to be O, S, T, T, S, and then two S's. So this is going to be F of C, and when we count them up, we see it's 1, 2, 3, 4, 5, 6, 7. So the probability that we get something in the complement of F is going to be 7 over the total, which is 17. And when you see what that is about, it's going to be about 0.412. I don't know if I've said this yet, but these symbols, that just means approximately. Whereas this means it's exactly equal. On a test, it doesn't matter to me. You can write either one. I'm totally okay with it. That's just going to be more of what I do when I write it. So don't be confused. It just means it's approximately, it's about, we're rounding. It's not exactly. But you can do whatever you want. I'm not going to take off for that on a test or anything. All right. So now we have the complement of C and F. Well, I guess, first of all, let's also notice something, right? So if there are 10 letters in F, notice it also makes sense that then there would be 17 minus 7, or sorry, 17 minus 10, which is 7 letters in its complement, right? So we also could have done it that way. All right. So now let's look at the complement of C and F. What's the probability of the complement of C and F? So C meant the consonants. Consonant, something like that. So if it's not a consonant, what is it? Hopefully you know that if it's not a consonant, it's going to be a vowel. So the complement of C is just whatever V is, right? The vowels. So looking at F and V, what are the ones in common? Remember, and means it's in both. Well, we see that we have an E in both of them. We have another E in both of them. We have an A in both of them, and we have another A in both of them. So how many numbers do they have in common? They have 4. Out of a total of how many? Still 17. Right? And when we divide that out, we get about 0.235. All right, now what about the or? Oh, so the or is going to be super important too. So if we wrote out the actual event, right? So remember we said the complement of V, or sorry, the complement of C is just all the vowels. So we can put an O. Is there an O in here? Nope. All right. We can put an E. Is there an E in here? Yeah, so we don't want to double count. We have another E. Is there another E here? Yep. Again, don't want to double count anything. We have an A. There's an A here. Good. We have another A. There's an A there. Good. So since we're all out of vowels, now we can just write the rest of the letters. So we got a C, an L, a G, a C, and an L. So the super important part with the or, you don't want to double count, right? So it's really important that we don't double count. There's not two, it's not 3 or 4 E's, it's only the 2 E's that we talked about, right? If you look at the actual numbers that, or the actual pieces of paper, right? Maximum, there's only 3 E's, or 2 E's, right? So you, on a piece of paper, you wrote E, and on another piece of paper, you wrote E. So you can't have more than 2 E's, right? All right, so when we count these up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We see it's 11 out of the total, which is 17. So when you divide 11 by 17, you get about 0.647. All right, so let's look at C and the complement of F. So we already determined the complement of F was O, S, T, T, S, 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 I believe. Let's just double check. Yeah. All right. So if we're looking at the and, right, the ones in common with C and this complement, we see that the consonants in common are the S, the T, the S, and the S. So how many letters are in common with both? 1, 2, 3, 4, 5, 6. So we get 6 over 17, which is 0.353. So remember, and is in common, or is in either. So again, it might be good just to actually write out what are all of the ones in this event and making sure we don't double count anything. Well, we can already talk about the ones that we've already circled, right? We know that the and is going to be in both. So we got the S, the T, the S, and the S. So you can kind of just cancel out all the ones we've already counted from both. And then you look at what's left over. So we have an O in the complement of F. And then we have a C, an L, a G, a C, and an L. So those are the only ones left over in C, right? Because again, don't want to double count any S's or anything. So when we count them all up, we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there's 13 out of 17. Which when you divide that out, you get 0.765. All right. So let's do V and C. So what are all the vowels in what are all the letters in common with the vowels and the consonants? Well, since we already talked about that the complement of the consonants are the vowels, they don't have anything in common, right? And you can look, vowels can't be vowels and consonants. And since there's no Y, we don't have to deal with that, right? So there are none of them in common over 17, which of course is just 0. And then what about if it's in V or C? Well, since all of our letters are either vowels or consonants, that's just all of them, right? And we can actually count it out. We end up with 17 out of a total of 17, which is just 1. Easy. All right, now this is a little trickier for some people, so let's just go back over the conditional stuff. So the probability of V given that we're looking at F. So this time, what's our population? The population is F, so you can kind of think of it as the ones in F that are also in V, right? So F is going to go on the bottom. So how many are in F? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 is the total this time. We're not looking at all of them. We're only looking at the letters in F. So looking at the letters in F, which are vowels? So what are the vowels in F? That's what this is saying, right? What are all the vowels in F? So we see that there's 1, 2, 3, 4. So 4 out of 10, which is 0.4. All right, now that's different than part L, right? Part L says, so for part L, what is the population? What are we looking at? So this time we're looking at V. So V is going to be in the bottom. And of course you see that there's only 5 letters in V. Now, out of those 5 letters, which ones are in F? So remember, F was the first half of the alphabet. That's A to M. So what are the letters that are A to M? Well, we see E, A, and A, right? Those are all in the first half of the alphabet. So that's 4 of them out of 5, because 0 is not in F. So that's 0.8. All right, let's do another one. So we have the probability of F given C. So what's our population here? What are the letters that we're taking it from? It's not all of them this time. It's only the ones in C. So C, we know, we've counted, right? That has 12 letters in it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Perfect, yep, 12 letters. So out of these 12 letters, which ones are in F? Which ones are in the first half of the alphabet? Well, we got a C, an L, a G, a C, and an L. So 1, 2, 3, 4, 5, 6. So half of them. And then let's do the opposite. So probability of C given F. So again, which one's your population? Which ones are you taking the letters from? You're taking them from F, right? So from here, which are the consonants? From F, which ones are the consonants? So we said again, there are 10 in F. So how many constants are there in F? 1, 2, 3, 4, 5, 6, which is 0.6. Part O. All right, so the probability of the complement of C given V. So again, we said that the complement of C was O. Whoops. All right, so I think I just messed things up. So we're going to pause, have a part 2 for this.